Okay, good morning. We are back. Here we go. We are almost done with the year. Can you believe it? I can't. It's very sad. What are you going to do, like, every single day when you wake up? You're like, dang, I should be in advanced algebra right now with Mr. McConey. I'm going to be sad because, what's better to start your day than with math? You know what I mean? Wow. You guys are so lucky. You get math first period. Well, you had math first period, I guess, for a couple more days. Oh boy. But, whatever. We can enjoy it while we still have it, right? Um, yeah. Okay. So today we are going to talk about logarithms, and we're also going to talk, this video is going to be about logs and exponents, all right? The log and exponents test, remember this one? This was a good one, all right? This is with a doozy and a half. Remember our log properties, all right? We need to remember our log properties when we expand logs, addition and subtraction, and multiplication, division, okay, exponents and logs. All right, what do they all mean? Okay, remember from a while ago that division means subtraction. Exponents mean I can bring it down to the front. So I have the log of a squared minus the log of, base 8 of b to the fifth. Now you can do all this step in one. I'm just going to show you the next part. All right, if you were able to jump right to here, that's fine. Okay, and if you can't read anything, well, that stinks because, well, I guess I'm going to be here if you're watching it, right? For sure. Okay, anyway, 5. Okay, come on, dude. Here we go. Let's get a pencil. 5 times the log 8 of b. Oh, that was fun. Division means subtraction. Remember that if I have an exponent within a log, I can drop it like a top, drop it to the front. Okay, here we go. So let's try let's try this one. All right, it's 7:30 in the morning right now. I'm just making one of these videos because what else would I be doing? All right, log base 7 of z. Remember, there's multiplication going on here. All right, multiplication means addition, like division means subtraction. All right, so I'm going to do plus. Now, I have this cube root. Remember, if I take the cube root of x, that can be written as x to the 1/3 as a fractional exponent. All right, so I'm going to rewrite this as, I'm going to do a couple steps here. Let's go like this. All right, so I'm going to go log base 2 of x plus log base 2 of y, and that's all. It's all to the 1/3. Okay, that's a 1/3. So then I'm going to drop that to the front, but only in front of that stuff that's in the parentheses, because that is the only piece that's being taken the cube root, that we're taking the cube root of. There you go. Boom. That's your answer. Boom. Boom. Wow. 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 Ha 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 ha. How. Wowee. Wow. Wow. Okay, so let's try this one. All right, we're going backwards now. We're going to condense it. If I have a number in the front, that means I can throw it like it's cold, throw it like it's old. I don't know. Number in front, throw it up back up top, and then addition means multiplication. Okay? So I'm going to do it all in one step here. 5 u to the 12th v squared. Cool. That's sick. Yeah, for sure. Okay, so now, remember, this means multiplication. This means multiplication. 1/2, what? 1/2, got to throw it like it's old, so I'm going to go log base 5 of 7, throw it back up, times 2 squared times 3 to the 1/2. All right, well, I know that 2 squared is 4, and 4 times 7 right here is 28. So I'm going to rewrite that as 28. Okay, this portion right here, 3 to the 1/2, well, that's the square root of 3. That's supposed to be, are you kidding me? Are you kidding me? Here we go, there we go. So that's supposed to be the square root of 3, and then the log base 5. Boom. Wowzers. Remember? Remember. Remember. Remember? Hey, where's it at? Oh, oh, oh. Believe you can. believe you can remember. Here we go. Let's do the next one. Let's graph it up. All right, we want to plot at least 3 points. Now, how do I do this? Well, you can plug this into your handy dandy little calculator here. All right, go to your y equals. I don't have that fancy little thing here, and do y to the 2x minus 4. Okay, if you do that, you should go to your table. 1, 2, 3. You should get 0, negative 3, 1, comma 2, and 2, comma 0. And if you notice, as x is getting smaller and smaller and smaller, my y values are approaching negative 4. They're never going to hit negative 4. And why is that? Well, remember, this negative 4 means I moved my graph down 4 from my parent function. So that makes, if I moved it down 4, that makes the asymptote y equals negative 4. Now, with an exponential graph like this one here, as x is in the exponent, okay, it's easier to tell exponential graphs have horizontal asymptotes, log graphs have vertical asymptotes. And when you have a vertical asymptote in a log graph, you're going to be able to see that on your table because you'll get an error message after a certain x value. Okay, that means my vertical asymptote is at that first initial error. All right, so here is your graph. Domain, if I put an x value in, it's always going to spit out a y value. So negative infinity to infinity. If I have a horizontal asymptote, then my range is from that horizontal asymptote to infinity. All right? We are flying. Remember, you can rewind. You can watch as many times as you want. Why wouldn't you? I mean, these are great videos, great production quality. All right, make sure to hit that like button, hit subscribe maybe, if you already haven't. Well, if you already have, I mean, you probably should, you know what I'm saying, for sure. Okay, so anyway, I have a log on one side here. Okay, I want to solve for x, so we're solving. If I want to solve for x, all right, if there's a log on one side, I want to rewrite this into exponential form. My base is 3. Remember, circle of life, 3 to the 5th power equals x plus 4. Okay, and then we can just solve it from there. 3 to the 5th power is 243 equals x plus 4. You should get x to be 239. I'm going to assume you can do that algebra. Okay, so check your work. All right, here, I have logs on one side, which means eventually I'm going to have to switch it to exponential form right here. But I have 2 logs. Well, remember, addition can be written as multiplication, so we're going to condense our log. So log base 2 of x times x plus 6. Now, Mr. Marconi, the x comes second. Well, if I wrote it second, it'd be the same thing. Okay, because either way, we're going to distribute the x to both numbers. Equals 4. All right, so just like this one, I have a log on one side. I want to switch it to exponential form. 2 is the base. 4 is the exponent. So 2 to the 4th equals x. I'm just going to go ahead and go x squared. Okay, come on. X squared plus 6x. 2 to the 4th is 16. I'm going to bring that 16 over, so 0 equals x squared plus 6x minus 16. So, guess what? We have to factor. That's fun. I'm so excited to factor. Here we go. 2 numbers are multiplied negative 16 and add to positive 6. Yep, you guessed it. X plus, don't copy my work, x plus 8. X minus 2. So set each factor equal to 0. X equals negative 8. And x equals 2. Now remember, you cannot take the log of a negative number, so negative 8 is deuces, and x is just deuces. X is 2. Wow. Wow, now this is going fast. I'm going fast. I'm on a time crunch here. I got to get to a meeting in 10 minutes. Don't want to be late, for sure. Okay, so now let's try this one. I'm going to rewrite. I have 7 to the 2x plus 1, and I have 1 over 49. Now, if I'm looking at this problem here, I know that 49 can be expressed as a power of 7. Okay, the number 49. Forget about the fraction for a second. I know that 7 squared gives me 49. Well, if that's true, then if I have remember, if you have a fraction, if I want to make this a fraction, I have to make it to the negative second. Negative second flips the number. Okay, negative exponent does. So since these bases are the same, set your exponents equal. If I have a 7 and a 7, it's 2x plus 1 equals -2. And you can do it from there. Same thing here, okay? I have a 3. I know that 243 can be expressed as a power of 3. So I'm going to rewrite that as not 2. Wow. 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 So 3 to the 5th, so I just set 1 minus 2x equal to 5. You having fun yet? I'm having so much fun. Here we go. Let's try another one. Let's go with a word problem. All right, we got 3 word problems, compound interest, okay? What are some good ideas to put something on your note card? The compound interest formulas. There's compounded continuously, which is what these problems deal with, all right? There's compound interest formula. There's also the half-life formula as well, okay? So if you go back to your exponents and logs tests, which you have, all right, they're all listed across the top, or if you look at the review guide from that section, if you lost a review guide, that's fine, but, well, just got jumpy there. But guess what? There's one posted on my website, all right? So a bank promises, this tripped us up a lot. A bank promises to triple your money in 15 years, okay? Compounded continuously. What is the rate, okay? So remember, I have A, if it's compound continuously, so that formula, A equals PERT formula. If I want to triple my money, okay, let's say I started with $15, all right? Remember, P is your principal value, your starting amount. If I started with 15, this would be 45. If I started with $1, this would be 3. I'm going to make it easy myself, okay? I'm going to start with $1. So this is going to be 3 equals 1 times E. I'm trying to find my rate, so that's still R. And T is 15. Okay? Now I want to solve for R, right? Well, my R is a variable in an exponent, okay? My base is E. So if I have an E here, that means I need to take the natural log of both sides, because the natural log has a base of E. So if that's the case, since the base is E, these cancel out, and it's the natural log of 3 equals 15R. Natural log, remember, is a button in your calculator. I'm going to divide both sides by 15. So R equals about 0.07, which is about 7%. Okay? All right. How about this one? How much compounded continuously? How much should be deposited? That tells me that I'm looking for my principal value at a 9% rate to have a balance of $1 grand, for sure. All right, a balance of 1,000 after 5 years. You know, I mean, if someone's walking by the hallway, they're like, what is that dude doing? And they're laughing by himself, just like staring at a computer screen, writing stuff. I don't know. Don't worry, I'm just making a great video. Oscar worthy. All right, my percent is 9%. Okay, so remember, or my rate is. So remember to write that as a decimal. I write it as 0.09 times my years, which is 5. All right. So that's 1,000 equals P times E to the 0.45. Remember, E is a button in your calculator. It's second natural log. The natural log button is right next to the 4. All right, on this left-hand side here, right next to the 4. Okay. I'm going to divide 1,000. Don't try to do that in your calculator yet. Do 1,000 divided by E to the 0.45. And you should get P to be about 637.63. This last one, I'll show you the setup. I got A equals 600 times E to the 0.0725 times 8. And you should get about 1,071.62. All right, I hope you enjoyed that video. If you have any questions, let me know. All right, another one comes soon. See ya.